All right, here we go. Last few problems. We need the lateral area. So that is the perimeter times the height, right? On a figure that has two bases that are parallel to each other, you just need to find the perimeter of the base and multiply it by the height. So the perimeter in this situation is called the circumference, and it's the diameter times pi, and then the height is 12. So you could put over here, well, you need to put 16 pi right here in square inches, and the surface, oh, I guess I need to put base in front of lateral area, right? You need to find the base. No, what am I doing? What am I doing? I'm sorry. I'm not going to make another video. Uh, Doggone it. This is the base area, not the perimeter of the base. So the perimeter is 16 pi. You'd think somebody else made this test up. I did this. And you multiply by 12 and you end up with so many square inches. Let's jump over to Desmos and figure out what that is approximately. So what did I just say? We want 16 pi times 12, right? 16 pi times 12 is 603.2. So I put 603.2 right here, 603.2 with a little dot over the equal sign, meaning approximately equal to. The base is pi r squared, right? The area of the base is going to be pi r squared. This was pi times diameter. And so I got 64 pi because I stick an 8 in for the radius. 8 squared is 64, right? So I could just put 64 pi over here. I don't need a decimal approximation. This saves you a little time, right? Now the surface area is this 603.2 number, 603.2 plus 2 bases, so 264 pi's. So we jump over here and we put down plus 2 times 64 pi, and that comes out to be 1005.3. I'm doing this really fast, right? 1005.3. If you see a mistake, we're going to talk about it in class, okay? The base, this one's a triangle, right? Triangle. So you go 1/2, one leg times the other leg. So 7 times 24, half of 24 is 12. 12 times 7 is 12 times 7 is I think 84, I hope. Okay, so my base comes out to be 84 square inches. All right, you notice I did the half times the 24 first, right? Let me just double check that. So I get 7 times, what did I just say? 7 times 12, and that gives me 84 for sure. The volume is going to be the area of the base times the height and a third of that. So I got to do 1/3, 84 times 28, right? I'm putting the base right here. This is the base, this is the height, and you got to take 1/3. So I could just go right here and go times 1/3, and then we got to multiply that by the height, which was 28. I see the height right here, right? The height's 28. The base was the 7 times 12, and so we took a third. Now, notice I put the third in the middle. You could put it out front. Doesn't matter at all. But my answer comes out to be 784. So see how the 1/3 is in the front, but I'm just putting it in the middle, right? So I'm going to put 784 right there. So 784 square inch. Oh, no, this is cubic inches because we're dealing with a volume. Oh, doggone, I put it in the wrong place here. Hold on one sec here. Let's put it where it belongs. So that's right up here, 784 cubic inches. Okay, sorry about that. Number 9. Number 9. Here we go. It's a right triangle for a base. This is the base that's like facing us right here. It's just not laying on its base. We talked about that. Like it's laying on this rectangle down here. Visually, that's what I'm seeing. But this is the base because bases are parallel to each other. So this is 12 long right here. And the area of the base is going to be 1/2 in a triangle, base times height. I know I'm using the word base twice, but that's the area of the base. And so we get 1/2 12 times 5. Where'd I come up with that 12 from? Well, it's a 5, 12, 13 triangle, Pythagorean triple, right? So that comes out to be 6. 6 times 5 is 30. That's the area of the base. Okay, so I put that right up here, 30. And the volume of this one is the base times the height. So we go 30 times 3. There's the height right there. This is the height, that distance. So I get 90 cubic meters. Okay. Oh, we're on number 10 finally. The volume of the cone. It wants the volume of the cone. So how do we do volume of a cone? It's 1/3 area of the base times the height. The base has a radius of 5. So the area of the base is going to be 25 pi because it's pi r squared, right? Pi r squared. So I go pi times 5 squared. That's 25 pi. So I've got 1/3 area of the base, and the height is that 14 distance right there, right? So I'm just going to save myself a little time here. You crank it out on Desmos, okay? Now it says, what's volume of half of the sphere? Well, the sphere has a radius of 5, and the formula for a sphere is 4/3 pi r cubed. So I'm going to go 4/3 pi times 5 cubed. Then I'm going to take half of that. I'm going to take half of that answer right here, right in there. And then we're going to add these two together. We're going to add this guy plus this guy right here. So let's jump to Desmos now and see if we can do some of this calculating. I'm going to put it like maybe right here. And let's see if we can move this over a little bit. Okay. Now, what do we got? We've got 1/3. So I'm going to do this stuff right here. 1/3 times 25 pi. And then I've got times 14. And then I've got plus this stuff right down here, which was, where is it? Oh, one half of 4/3. So I go 1/2 of 4/3. Oh, geez, that's looking terrible. 1/2 of 4/3. No, I don't like that either. Let's do times 4/3. Okay, now it looks better. And then we're going to go times pi, and then times 5 cubed. So I just did 4/3 pi 5 cubed, and I took half of it, and I'm adding it to this base right up here, and I get a total of 628.3. See if you can get 628.3 right there. 6